In this video, I wanted to go over piecewise functions. We'll go over how to graph and how to write the function given a graph. So first, let's start with an example. If we were given a function, it's usually written like this, where we have kind of two equations or more. We could have more information here. So let's say we are given this. And what's different about piecewise functions is they kind of give us some little identifiers over here or more information about when these equations apply. So let's look at this for an example. What we are saying here is, what I always like to remember is we think of f of x or a function, we also call that y. So essentially what we're saying is we have two equations here. We have when y equals negative 3x minus 1 and y equals negative 5. It always looks a little bit strange when we're in this kind of function squiggly format. But if we think of them as two separate sections, two separate equations, that really, this now looks like, oh, that's just a line. That is mx plus b. That's a line format. And this, if we remember, is a horizontal line. That is when y equals negative 5 always. So if we think about just these two functions, if we were to graph them separately, y equals negative 3x minus 1. So if we remember, I call this home mx plus b. b is our y-intercept. So I know my y-intercept, or where I cross the y-axis, is down here at negative 1. Then my m is our slope. So in this case, if there's no fraction, it's just negative 3 over 1. So I know that I'm going to rise over run. I'm going to go down 3 because it's negative. 1, 2, 3 over 1 to the right is positive. If I go negative, negative, that's really a positive, right? So if I go down and left, that would be right. I'm sorry, that would be positive. But if I go down and right, that would be negative. That's a little bit confusing. How I also like to remember it is kind of going this way is a negative slope. I always remember y equals x as a positive slope, so it goes that way. That's just a quick reminder of what is positive and negative slope. So in this case, this would be this entire line, and it goes on forever. What we're saying with the piecewise function is I'm only caring about half of it, or a part of it. I'm only caring about a part of that equation. So in this case, I'm only caring about this line when x is less than or equal, this is the equal or equal, to 1. So at positive 1, I'm going to think about when x is positive 1 here. What is less than 1? Less than 1 is going to the left, right? Everything here, this is all less than 1. So in that case, I'm going to only care about that portion of the line. So I really want to figure out what is occurring, what y exists when x is 1. So I either can go to my graph and I can look and see that point, or I can plug in that number. So if I were to plug in 1 in for x into this equation, what I'm saying is y equals negative 3 times positive 1. I'm going to let x equal 1 minus 1. So if we do this math, negative 3 times 1 is negative 3 minus 1 equals negative 4. So y equals negative 4. When x is positive 1, y equals negative 4. For just this top equation. And since I can be equal to 1, we are going to exist at that point. So, and thankfully I've graphed my graph correctly because I'm down here at negative 4. So that makes sense. I can either plug in the point or just look at the graph and do, as long as I do my slope correctly. So in that case, I'm only caring about the negative, or I'm sorry, less than 1 for x. So I'm only going to go to the left here for these values of x. And in that case, it's this portion of that top function. And because I am equal to, I'm going to have a solid line or solid dot here at 1, -4, because that does exist, or it is included in my equation here, in my function. So that's the top equation. Now let's think about the bottom. So the bottom one is y equals -5. Well, that is just a horizontal line down here at -5. So at -5, a horizontal line, this would be y equals -5 always. But I don't want it always. I only want it when x is greater than 1. So greater than 1, I want to think about going to the right, things that are bigger than 1. So when x is bigger than 1, that's what I care about for this graph, for this part of the function. So I should have erased this other line at the beginning because we only want that line, the purple part here, for that other one. So now for the bottom one, I'm going to go down here at 1 when x is +1. It would still be -5, but I'm an open circle. So sometimes we have to plug it in even though it's not equal to, just to find out where our dot is. But I'm going to be an open dot because I don't exist at that exact location. So it's right below, it's in this same line with this other x. So they're both when x is 1, just one is included and one is not. So then I'm going to go to the right and it's going to be a horizontal line at -5. So this is y equals -5 when x is greater than 1. So that would be the graph of this function. This is a piecewise function. My left-hand side is the top when x is less than 1, and it's -3x - 1. I have a -3 slope, and my y-intercept is still here at -1. So those are some things we can check. -5, I like to think of y equals -5. I recognize that as a horizontal line, and it is only when x is greater than 1, but I'm not going to include exactly at 1. So that would be that's an example for graphing given an equation. So now let's do one where we are, where we have more. Let's just do one more graphing when we have more of an interval. So let's just do real quick here. We have 1 and 3, and this is only when x is -4, less than or equal to x. So this would be between, when x is between -4 and -1. And then for this one, let's say it's from -1 to 2. So real quick, we recognize these as y equals 1 and y equals 3. So these are just two horizontal lines. Y equals 1, this would be always, and y equals 3, always. So those would be two horizontal lines, but we don't want all of them. So we only want it for a portion of x. So for the first one, I'm going to let y equal 1 only from -4 to -1 for x. So I'm here at x, -1, 2, 3, 4. That would be -4. So I'm equal to -4, so I can be equal to -4, and then this is only a horizontal line up to -1, and then it would be open at -1. So I'm here at positive y of 1, and then for x, it is only this little portion from -4 to -1, and I am not equal to -1, so I would have an open circle there. So then let's do the bottom one. If I am at 3, we'll do it in a different color here. Y equals 3, but I only care about from -1 to +2. So I've already graphed -1, 1, 2. Let's say that is +2 here. So I'm going to let, at -1, I can be equal to. So I'm going to draw a solid circle there. So when x is -1, y is 3. Then I'm going to have a horizontal line all the way over to positive 2, but I'm not equal to. So I would have an open circle there. So anytime you're asked for something in between, if someone were to say, so evaluate this when x is, so evaluate this whole function when x is 0. So your teacher might ask something like f of 0, and you would need to fill in the blank. So for this one, f of 0, right, we could either graph it, or we could just look here. If we were only given the equations and we didn't need to graph it, we could look here and figure out, well, where does 0 fit in? 0 only is included in this portion, right, because 0 is greater than -1, and that's not included in that top equation. So for that one, we would just know that 0, when f is 0, I'm sorry, when x is 0, f or y would be 3. Or it would be this second equation, meaning I only use these numbers for x, and then f is 3 or y is 3. Or I could just look down here at our graph. When x is 0 here, I would go up. The only point included when x is 0 would be when y is 3. So that would be kind of a little step function. Sometimes we're given these crazy piecewise functions that kind of go on forever. So it just depends what you are given. But that would be graphing, again, given an equation. So now let's switch gears and let's draw a graph. If we were given a graph that looked something like this, let's say we have a graph that looks something like this. Okay, so let's say we have this, and we'll pretend this is all nicely to scale. So this would be 1, 2, 3. We'll call this 3. So if I'm just given this graph and I need to figure out what these equations are, I know I'm going to start with f of x equals, and I'm going to have my squiggles. So I usually start with the left-hand side and think, okay, this goes on forever to the left. So it's all my x's all the way up until positive 3. So we would write that as when x is less than or equal to 3. So that would be for everything, including x, including 3, everything less than 3 and including 3. So now we've just got to figure out this equation. So this would be given on nicely graph paper, but let's just say this is positive 1 and this is positive 1. So in that case, we can count our slope and say, well, I've just gone up 1 over 1. And we can double check up 1 over 1, up 1 over 1. So that slope would be 1 over 1, but I know I'm going to the left, or I'm going rise over run, I'm going up, which is positive, but then left, which is negative. So that would be a negative x, or a negative 1 over 1 slope. So if I'm looking for mx plus b, this is a line, so that's the format that I'm looking for. My m is negative 1 over 1. So that would be a negative x, and now I just need my y-intercept, and I know I'm at positive 1 for my y-intercept. So I can always plug in stuff to double check, right? If I had a point up here, let's say, I'm not sure what that would be, but let's say it was here, and I could figure that out at negative 4, and this would be at 5. That would be 5, I think, right? So I can always plug in stuff and make sure my graph matches. So to make sure my equation matches my graph, I can plug in numbers and just make sure that that all works out. So when x is less than 3 and equal to, I have this left portion, and this would be my equation. So now let's look at the right side. Now I usually start with my interval, and I'm saying, okay, it's also 3. So x is greater than or equal to 3. In this case, we typically wouldn't have both because that would be kind of confusing. So I'm going to go ahead and make this an open circle. But if it is, we would just include that. So this would be an open circle. That would be for just greater than 3. So again, we would just check the slope. So we would go, it looks like here, looks like we're going over 1 up 2, or up 2 over 1. So that would be a 2x, or our slope of 2. We know it's positive and it's slopier, I always say, or a greater slope because it's more steep, more slopey. So that would be a greater slope of 2, up 2 over 1, looks like. And then I need to know my y-intercept. So I could either plug in some other points. Let's say here we have 4, 5. So for here, let's see, if we are at, let's say this is at 3 comma, looks like 2, right? So this would be much easier to see on a nicely scaled drawing. But for here, we're a little bit out of a loss. So I'm going to plug in 3 and I need to get 2. So if I do 6, 3 times 2, that would be 6. I need to get 2, so I'm going to subtract 4, which makes sense. That would be here at -4. So again, I'm not including this portion of the graph, or this portion would not be given. I just sketched it so that I could figure out the equation because I need to know that y-intercept in order to get that equation. So it's a little bit confusing, but when you're given a graph, you just have to be able to use the scaled drawing to your advantage to find some of those information. Usually it would be a lot easier because you could immediately see the y-intercept or extend the line so that you could see it and just make sure you count the slope to make sure you've got that exact point to find that y-intercept. So that would be writing the equations given the graph. So those are some piecewise functions. If you have any questions, feel free to comment below.